So, this is a little video for the Mr. Carlsons Lab project that he started on Patreon. If you're not a patron of Mr. Carlson, do what you need to do, but the guy seems to be producing some cool stuff, so I'm happy to help him out. He's got starting with a project, a low distortion sine wave generator. So a signal gen, but with the design parameters being low distortion. So he thinks it's getting somewhere below 0.1% total harmonic distortion. What our goal is, and that's just based on an opamp and a lamp, some bulb, well, a filament, because the filament has a resistance curve based on temperature. So it forms a natural oscillator. As the current increases, the temperature will increase in the filament. That will increase the resistance, and therefore reduce the amount of current flowing, so you get an oscillation effect. And then there's probably some hysteresis in there about the temperature of the filament. Well, anyways, that you can go to his site to find out all of the information about that. But what we're trying to do is we're trying to emulate that circuit, and then we're going to see if we can extend it by adding a couple of digital pots in order to change the frequency at which the signal generator is producing a frequency, and then hook that up to an Arduino and a display so that we can get some kind of a useful tool that has a user interface to allow you to understand what frequency you're putting out in your frequency generator. Yeah, I thought that would be a fun little add-on project to building a low distortion sine wave generator. But anyways, we'll see how far we get. We got an op-amp from our local parts store, but sadly they only had one digital pot, and you need two in order to to have both sides of the wean bridge change resistance together to increase, sorry, not the amplitude, but the frequency. So yeah, that's what the plan is for tonight. Okay, so we've breadboarded up the circuit roughly according to what values are specified in the schematic. I mean, this is these pots are okay. That one's 100 ohm pot, and this one is a 10K pot. I haven't done any trimming. 1500 ohm resistors here, 0.1 microfarad variable or electrolytic caps. This is a 5-volt battery, or a 5-volt bulb, well, it's from a snake light, what I made my soldering station out of. Anyways, the bulb's out of that, and then I've got a 10K ohm variable resistor load here. So it is producing an output, but it is looking very clipped. It's not exactly a sine wave at all. So there's some tuning of the circuit that needs to be done. All right, so I've trimmed the voltage so that it is 2 volts peak to peak, roughly, but the peaks are flat. This is not a sine wave. So elsewhere in the circuit, I need to go investigate how that thing is getting clipped so badly. And I think, well, obviously it's on the other side of the input to the op-amp. So using a different light bulb rather than this, oh wait, what's going on? There we go. I've got a flaky connection in my board. So using a different bulb definitely gives you a different signal from the from the low voltage bulb. So regular, this would be, you know, an appliance bulb, 40 watt appliance bulb, gave me that waveform. So I guess swapping in different bulbs to get different response curves is what's needed in order to bring the THD down. Now, I could try and do some FFTs on that, and I think I might try and capture it with my digital storage scope that I built, and we'll see how that goes. Okay, and so this is the fast Fourier transform of a capture of the signal coming out of the out of our device, and this looks like the fundamental frequency, and then we've got harmonic spikes, I think, and I'm not sure what all of this is. This might be sample noise, or it might be noise coming from the signal, and I'm thinking that it's noise coming from the signal, but I'm not 100% sure about how exactly to read the fast Fourier transform. But that would be my guess if I had to make one. So yeah, this software here, and this little job here is the AJ scope. I think I've got a couple of videos up on it, but if anybody wants any more information and links, they'll be in the description. And yeah, I maybe make another. I've got to build a new video, or got to build a new circuit board for this thing, and I might make more videos on it. Anyways, yeah. So it looks like we have a somewhat functioning signal generator that is a little bit impervious to mechanical stress on the bulb, probably because it's operating at such so far below its rated value. And we've got our little circuit board prototype connected with some trimmer pots so that we can assess values. But obviously I'm not getting a symmetrical sine wave, and there is noise you can see at the top and the bottom of the signal. So I'm thinking that I have to do some more searching for bulbs before I get the right values that will produce a nice low distortion sine wave for tuning. But anyways, that's some progress. Thanks for watching.